All right, looks like we're live. Hello everyone and welcome to yet another Zozin session. How about that? Let's make a little bit of an announcement and start at sorting. Red circle live on Twitch, right? So, and what we're doing today is a very interesting topic, by the way. Today we are adding support for macros to our programming language, so it's actually quite exciting for me. So yeah, there we go. So we pinged everyone and Yesu. So you can find the source code of the language we're developing in the description if you are of course interested, and you also can find the playlist of the development episodes there as well. Hello Irish Bruce, hello, welcome to the stream. So yeah, and if you're watching live, you can find the source code here in the chat. So let's take a look. I don't remember what we were doing in the previous stream. I think in the previous stream we were adding support for string literals. This is actually quite important. Yeah, we were adding support for string literals, and finally you can write hello world in this language with one single line. Bstream, hello. Membrilla Amarilla, Stavsin, Mr. Botka, hello everyone. How are you guys doing? So, Yesu. But there's one inconvenience in the current state of the language. One of them is that you have to repeat nonsensical things, right? If you want to do hello world, you have to put like 1 syscall 3, and the question is, what is that supposed to mean? And also, if you take a look at our example that demonstrates that the language is Turing complete, it's filled with magic numbers, right? So, and it's unclear what those magic numbers mean even, and we don't have any mechanism to tuck those magic numbers under some sort of like a constant name. You know how in C I could have defined something like n, or maybe board size, and say that it's 100, and instead of 100 I would use board size, and whoever reading this code, they can instantly say, okay, so this is the board size, and here is the single place where you can control all of that. We don't have that mechanism, so we have to duplicate a lot of code. Right. So, and this is precisely what I want to address today. So, are you planning on having the compiler be able to cross-compile, or just Linux for now? Yes and yes. So we're going to support Linux for now, and in the future we're going to support cross-compilation. So if you take a look at the source code of the compiler itself, the function that generates assembly, is called generate. Let me take a look. Oh yeah, I recently actually did a little bit of refactoring, so let me actually fetch the latest changes. So let's do git clean fdx, right? So, and then let me fetch the latest stuff. Let's go to the master. Let's merge origin master, and let's remove this branch. Okay, so recently I did a little bit of refactoring, and finally I replaced my handmade enumerations with the Python enumerations. Apparently Python had something similar to IOTA, right? So it's basically auto, and you have to sort of derive from enumeration. And I started to use data classes because it's just easier to document what kind of structure I expect. So we used to use dictionaries and stuff like that. Right, and I also added a little bit of typing around, right? So the recent Python has support for different typing, and it's not great per se, right? So the utilities that check typing, they're kind of clunky, but it's good for documentation at least, right? That's what you can get with such a dynamic language. At least it's something. Okay, so back to the question. So the function that generates assembly, it's called generate nasm linux x86-64. And what it does, it accepts a program. And program, if you take a look at the definition of the program, program is a list of operations. Right, so this function implies that you're gonna have more different generators. So right now we only have generate NASM Linux x86-64. Maybe in the future we're gonna have generate NASM Win32 x86-64. Maybe in the future we're gonna have generate Linux ARM. Right, and all of these functions are going to have the same signature, and they're all gonna accept a program, and from the program they're gonna generate like programs for different targets. But for now we have a generator only for Linux x86-64. So hopefully that answers the question. So yeah, essentially. All right. So yet again, let's go back to the original problem that we have. I want to be able to talk some of the magical constants under some certain name. And I also want to kill two birds with one stone. We do not approve of animal abuse, by the way. And I want to be able to essentially, in a hello world specifically, being able to just get these three things and assign a single name for them. And I'm thinking about introducing some sort of like a macro system. So a macro system, like if you want to define a macro, you would start with the keyword macro, and then you provide the name for the macro. Right. And after that, you provide a sequence of operations that define the macro, right? So here is a sequence of operations. So this is the write macro. And then you say, okay, I'm done with the macro. This is where the macro ends. And now, every time you sort of like use write, during the compilation, this single token will expand into these three tokens, right? So that way you can define like convenient macros, right? So you'll be able to write. So it's kind of similar to preprocessor, but hopefully it's not gonna, you know, make the same mistakes of the preprocessor. So I actually plan the macro system be more aware of the language itself, right? Because the preprocessor in C is a completely separate utility, completely separate language on top of C that is not aware of the C context. In our case, it's not going to be the case, right? So macro system is part of the language, so it's aware of the context, and maybe we're going to have some features that are aware of the language itself. All right. All right, so how a macro system would also allow us to have magical constants? Well, so you can use the same system to just define a constant, essentially, right? So if you want to define something like board size, you would do it like this, right? And then you would be able to just use it like that, right? So it's the same system, right? Essentially, you define a macro that expands a single word into a sequence of words, right? So, and this is precisely what I want to implement today. And I think it's a relatively simple feature, but it enables a lot of code reusage. It's not the best way to reuse the code, right? You know, something like procedures would be better, but it's something that is easy to implement right now. It's like a low-hanging fruit, if you know what I'm talking about. So, and that's precisely what I wanted to implement today. So let's go ahead and do that. It's such a cool way of doing compilation. Looking forward to you covering optimizations when we get around to that. I'm also looking forward to optimizations, right? So I've never done any optimizations before, and I'm definitely looking forward to that. All right, so let's go ahead and actually start the development, I suppose. So let me just clean my current state. All right, so let's just clean everything. And I think I'm going to create a separate branch, right? I like to do my development in feature branches, right? Macros. Did it create a branch? No, it didn't create a branch. Macros. How do I create branches? I forgot how to do that. Okay, finally. So it was so hard. I forgot how to create branches at all. All right, so we're gonna start with maybe, I don't know, maybe modifying our hello world. How about that? So I'm literally gonna go to hello world and I'm gonna try to modify it. So I'm gonna like introduce the thing that I demonstrated, macro write, and then I'm gonna do and instead of this thing, I'm gonna say write, right? And if I try to compile this thing right now, or something like, let's not compile, but simulate rather, hello world Porth, right, it will say that we have a known word macro, and it actually shows that in a really weird spot. It's supposed to actually show that in here, but it's just Emacs being Emacs, right? So so the actual reporting of the location is correct in this case. So the first thing I want to do, I want to introduce a new keyword, right? So where are we going to put that keyword? So this keyword actually forms a new block, and we have block forming keywords here. So if and else, and also while and do. Maybe I should actually put them somewhere nearby, right, to indicate that they form blocks or something like that. Maybe I'm going to just emphasize that these are like sort of block forming keywords, and I'm going to introduce a macro. There we go. So we have a bunch of assertions that check for that we handled all of the operation types. So let's actually go to the assertions real quick. So this is going to be Porth py, simulate examples, hello world. This is going to be the Porth. Okay, so here we have a non-exhaustive definition for the built-in words. Okay, so this is basically a mapping from a name of this thing to a particular operation type. All right, so I'm gonna actually move this thing in here. Right, so this basically explains how the Lexer should assign the operation times based on the names that it encounters in the source code. So this is going to be macro, op type macro, there we go, and let's try to recompile. Okay, so I have to increment 36, right? Okay, so unknown word write. Okay, this one is very interesting. This one is very interesting, and it's kind of annoying that it reports everything incorrectly. It reports everything incorrectly. So maybe I can actually fix the reporting location somehow super quick. So the location is defined in here. So here is a lock. And I suppose for a really quick fix, I can just put +1 in here, and hopefully that will report everything correctly. And there we go. So it reports everything correctly. So what it tries to do, essentially, it basically parsed macro, and now it tries to parse write, and it right away tries to identify what kind of operation it is. But I think we shouldn't do that. The reason why it tries to do that is because we pre-compile all of the tokens into operations and only then do cross-referencing and stuff like that. So if I go into compile tokens to program, right, before going through all of the operations and doing cross-referencing for the blocks, right, if, else, do, while, they all need to cross-reference each other to know where to jump to when a condition is true or when something else happened, right? So first we convert all of the tokens and only then to do that. So I think what we have to do in here, we have to change the way we convert tokens into operations, right? We have to convert them into operations lazily, sort of more lazily. Don't try to convert them all at once. Get the next token and only then try to convert it or something like this. Does it make sense? Hopefully that makes sense. So how are we gonna do all of that? This is a very interesting question. So tokens. So IP is instruction pointer. We do not really reassign IP to any different places. So one of the things we can do, we can essentially get rid of this entire thing and say the program is going to be completely empty. And then we're going to consume tokens one by one, I suppose, right? Something like current token. Or maybe there is a way to pop the element from the list from the beginning, if you know what I'm talking about. I don't really know Python that well, so let me see if it is possible. So this is going to be Debugging, Porth, and let's go and see what we have in here, right? So 1, 2, 3, 4, and I'm gonna assign it to access. And I suppose pop actually does that from the right end. And how do you do that from the left one? Is there any parameter in the pop? So method of built-in. Okay, so oh, I see. So by default it's -1, and that's why it does the last element. So can I do something like access pop 0? And it actually do that from the beginning. This is precisely what I want to have. Is it always like O of 1? Is it always O of 1? What's the complexity of this operation? Does anyone know? Remove and return index rises. Of course, an average Python developer is not supposed to know the complexity of such operations. Am I right? So I don't know. Python list pop complexity. Right. Yes, it is pop to the last element Python and to pop arbitrary element. So just to make it clear, pop 0 is n? Really? Really? It is n? Like 100%? This is actually really strange. Is it like an old information? Did they change that in Python 3 or something? This is actually really sad. I really don't like that. So well, it is what it is, and it isn't what it isn't. To be fair, the performance of this compiler is not really that important, so maybe whatever. Maybe we're gonna do like off an operation and it becomes super slow. But then I'll have to profile to know what exactly makes it slow. So maybe it would be better to actually account for that starting from the beginning, right? So it's better to account for that starting from the beginning. Oh, and also when we expand the macros, right? When we expand the macros, we'll have to append them to the beginning as well, right? We'll have to append them. This is really annoying. So maybe we can just reverse the tokens, and every time we append, we can reverse them as well. So this is really strange. Python is a really strange language, but yeah. Okay, so let me see. So if I do reverse, right? So what? Oh my god, why is it so slow? It's a reversed. Is a reversed a pure function? I think it is pure, right? So is it pure? Return reverse over the values. But then okay, so and another question. So if I have several things, can I append a list of other things? Is that something I can do? Well, that was not actually ideal thing to do. So, but I suppose I can do something like this, right? So this is how we do that. Okay, that's fine. That is totally fine. Okay. So our tokens, reversed tokens. So maybe I'm gonna actually convert it to a list, right? So and while our tokens length is greater than 0, right? We're gonna essentially take the next operation. But what's interesting is that now we have to maintain the IP somehow, right? So IP is going to be 0. IP is going to be 0, and so we take our tokens, we pop that token, and we need to now compile that token to the operation, right? So we're compiling that token to the operation, right? And now at the end in here, we have to increment the IP, right? There we go. So that's basically what we need to do, I think. Let's go ahead and try to run this entire stuff. All right, so let's take a look. So this is going to be 36, right? So this is going to be 37, and yeah, there we go. Now let's take look. Else if op type is going to be equal op type. Macro assert false, not implemented. Right, there we go, not implemented. There we go, so we actually hit that place. So essentially when we encounter a macro, we kind of have to change the way we start parsing everything, right? Specifically, the next token that we encounter should not be parsed as an operation. Freefu, thank you so much for 6 months of tier 1 subscription. Pog indeed, thank you, thank you, thank you, and welcome to our epic Pog Club. That's right. Cheers, by the way. Thank you so much for the subscription. What is your Codeforces rating? I see you have ICPC t-shirt. It's actually pretty shitty rating. So even though I have ICPC t-shirt, I was never good at competitive programming. So you can find my profile by the name Rexim, right? So, and I actually haven't participated for quite some time. This is not me. I accidentally clicked. Maybe this is me. Who knows? Why this website is so slow? Yeah, you can find it in here. So this is my profile. As you can see, I was never good at it. So yeah, I'm pretty shitty competitive programmer. So sorry about that. All right, so let's continue. So the next thing we need to do. I'm also thinking that we need some sort of dictionary, right? Dictionary that maintains current macros, right? So we're gonna have something like macros, and this is gonna be a dictionary. And since we're using typed macro, we need to do something like this. So this is gonna be a dictionary, a string, and maybe we could define a structure called macro, right? So it's gonna be a class. And let's say that it's going to be a data class. Are you guys familiar with the data classes in C? Oh, not in C, in Python. I recently discovered them, data classes. I actually rewrote my entire program from like dictionaries and handmade enumerations to Python enumerations and data classes, and it became twice as slow. But at least it became readable, so that's something. Right. I don't know how, but it straight up became slow, especially the simulation. So yeah, I call it a win. We can even check that, I think. I think this is something that can be easily checked. So let's actually go and do that. So I'm gonna go to the master and remove name procedures. I don't remember. Oh yeah, so this is basically where I did that. So this is before I introduced enumerations and data classes or anything like that. So this is basically the old implementation. Right, so let's actually confirm that it uses dictionaries. Yeah, it still uses dictionaries, as you can see. So dictionaries are fine. And let's try to simulate the rule 110 example, right? So how much time does it take to simulate rule 110? It takes 1.2, right? So this is how much time it takes to simulate that. 1.7, 1.6, or something like that. So this is like an average thing. All right, and then maybe it's gonna be fast this time, I don't know. So let's actually go back. And somewhere around here, I rewrote everything, and let's see if it became slower or faster. Yeah, so now it takes 5 seconds. So it's absolutely equivalent code, by the way, right? It's just one uses, dictionaries instead of data classes, and, integers instead of enumerations, and this is the difference in performance. But hey, at least it's more readable. Am I right? Right. So who cares about the users if the readability is more important, right? Developers are more expensive than users. Anyways, so let's continue. I love Python. Python is my favorite language of all time. It's just beautiful. Absolutely beautiful language. So let's continue. Oh, we got gifted subs. Deep Singularity gifted 5 tier 1 subs to the Tsoding community. Holy fucking shit. Thank you so much for gifting the subs, and everyone who got the subs, welcome. I haven't been to the stream in a while. Is that a dabbing wooden figure in the back? It actually is. Somebody finally noticed this. So just a second. Yes, it is dabbing. So it's actually a dummy for drawing, right? So artists use this to basically for poses references, right? And I just put it in a dabbing mode. This is how you dab. A thick book? You want to know what is this book? I can show you. It's a introduction to algorithms, but translated in Russian. It's a CLRS, right? The famous CLRS book, but it's in Russian, right? Does anyone speak Russian or reads Russian? So, yeah, it's pretty cool book. GF Waz subscribed for 5 months with Twitch Prime. Thank you so much for subscription and welcome to our epic introduction to algorithm clubs. You know Russian? Yeah, I studied Russian for 30 years. It's actually a pretty cool language. So, alrighty, so let's continue. What do we have? We wanted to introduce a data class for a macro. A data class for a macro. So where is it? So there was a compile program, right? So was it compile a program? I think I still haven't, oh yeah, I still haven't updated my thing, so I need to revert the buffer. Compile file to program. Compile tokens to program. Okay, here it is. So here is the class macro. And what macro is going to consist of? I suppose it's going to consist of a sequence of operations, right, that you need to substitute. And does it need to contain anything else? I feel like it will need to contain the location of its definition, right? If you know what I'm talking about. But maybe it's not really that important. No, it needs the location of its definition, right? Because the operation only will contain the things that are between macro and end, right? So it will only contain that. But the location should contain the location of the macro, so we can actually report everything properly. So the class is going to consist of these two things, I suppose. And macro is going to be a dictionary from the name of a word to a macro structure, right? And then we know what we need to substitute in here. Okay, so that's pretty pog. When we start a macro, right, we need to look into a next a token, right? So we need to take a look at next token. take a look at next token. So, and that means we need to do our tokens pop, right? If our tokens length, right? If our tokens length is actually equal to 0, this is where we have to report an error, meaning that you started the macro definition, but you didn't give any name for the macro, right? And we ran out of the tokens. So the situation like that may happen when you do something like this, right? So this is precisely the situation, right? So you study the macro, but then the stream of tokens abrupted. And this is what we need to report in here. We have to say something like sdd. So s is going to be the file path, row and column, and we're going to say error unfinished macro definition, right? So here is the unfinished macro definition, and the location is going to be, I suppose, the location of the OP, right? So OP does have its own location, hopefully. I think it does. And then we're gonna exit with 1, right? So if I try to compile this entire thing now, so it's gonna be Porth simulate hello world Porth. It should say unfinished macro definition. As you can see, it points at the beginning of the macro definition, right? So I go in here, it says unfinished macro definition. Makes sense. That's pretty pog. So the next thing I need to do, I need to get the name. So I'm going to take our tokens, I'm going to pop the name, and I want to assert a very important thing, right? So the name has to be a word, right? So we have different kinds of tokens. We have different kinds of tokens. Token, where are the tokens? Specifically token type, word, integer, and string, right? So Emacs is a little bit too slow. So the word looks like a symbol, right? So this is a word. This is an integer. It's a sequence of digits, and a string is a string literal, right? So we only support words as the names for the macro. You can only provide a word, and this is what we need to assert. Okay, so let me see. This is going to be to do. If name type not equal to OP token type word, right? Token type word, we have to say something like print sd error macro name can only be a word, right? If that makes any sense. I'm not sure if it actually explains anything to the user, but at least I'm trying to explain what the user is supposed to provide. So, and in hello world, let's actually try to do something like a 69, right? Macro name can only be a word. It would be kind of cool to also say what we found, right? Maybe something like expected a word but found an integer, right? Expected a word but found a string. So it would be kind of nice to say something like this. So we need a way to convert you know, token type into certain name, right? So I wonder if there is any convenient way to do that in Python, but I'm not sure. So macro name, expected macro name to be s, but found s, right? And in here, I suppose I'm gonna append additional things into the tuple, right? So we expected this entire thing to be a token type word, right? Token type word, but it was name type, right? So the question is like, how are we gonna do all of that? How are we gonna do all of that? So something, not enough argument for the format string. This is probably because I have to do something like this, right? So I have to do something like this, and there we go. So it kind of works. You see, expected macro name to be token type word, but found token type int. But it's kind of lame, if you know what I'm talking about. It's kind of I don't know. So to make it less lame, we have to come up with the with some sort of a table or some sort of a function. I don't know. We can probably do that. So let's see. I have a couple of ideas. Maybe we can have a function like human name, right? And then we can accept something like a type, right? And type can be, well, I don't know. So I could come up with a function like op type human readable name, right? So I could try to do something like that. Op type, and this entire thing returns a string, right? Maybe I can do assert false unimplemented, right? Or maybe not implemented. So, but the problem is this is going to be too long. Op type human readable name, op type human readable name. So it's kind of long, and I really don't like that. So, but I don't have a better approach for that, unfortunately. Also, maybe it would be better to actually do something like this. So it is what it is, I suppose, and it isn't what it isn't. So if type is equal op type word, we'll have to return a word, right? Else if type op type integer is going to be integer. If type, it's not really type, but type op type str return string, right? And else is essentially going to be assert false unreachable, right? So this is unreachable, and we're also gonna have something like assert length of op type. So here we expected 3. It's not op type, oh my god, it's a token type. Right, so it's a token type. There we go. It's a token type, and here we're going to say exhaustive handling of token types in token type human readable. In token type human readable. So basically, if we add more token types in here, so this assertion will tell us that we need to add more stuff in here. Okay, so let me see. So this is gonna be OP. Where is that? Token type. So, and now if I try to compile, there we go. So macroname, expected macroname to be word, but found int. Okay, that's actually pretty cool, right? So, and now you can say something like, maybe I'm gonna even do, not really int, but integer, right? And there we go. So expected macroname to be word, but found string, and then yet again, expected a name to be word, but found integer. Yeah, that's pretty cool. That is pretty cool. Okay, go. So now let me see. Token type human readable name. All right, so that's fine. Now, after that, we need to gather all of the tokens that we have until we encounter end, right? So we need to get everything until the end. So I wonder how we're going to do all of that. First of all, we probably have to define a new macro, right? So a new macro is going to be a macro that accepts the location, right? It's going to be name, OP location rather, and an empty list of operations, right? So it's going to be empty list of operations. I suppose we need to take the next one. So I'm going to do OP. This one is rather interesting, right? This one is rather interesting. Because now I just need to fetch the tokens until I encounter end or until I encounter the end of the stream, right? So that's essentially what I have to do. And it's kind of weird, not gonna lie. So if our token's len, right? If our token's len is equal to 0, this is straight up unfinished macro definition, right? So I just realized that it would be better to actually put this thing in here. Expected macro name, but found nothing. Right, I think it would be better actually. Right, so we encountered the end, and then we found nothing, essentially. But found nothing. The thing is, I wanna sort of reuse this variable for the next tokens, if you know what I'm talking about. If you know what I'm talking about. Right, so maybe I'm gonna rename this name to just token, right? So this is gonna be token, name lock, name token. And then, if this thing is equal to 0, we should say that we expected something. While this thing is greater than 0, I'm gonna do token or token swap, right? Token or token swap, and if token type is equal token. This one is rather interesting actually. So we need to pre-parse those things somehow. So we can try to do that. If a token type word and token value is equal to end, we're going to break the loop. Otherwise, oh shit! You know what? This is a very interesting situation, right? So what if we refer to things in a macro that do not exist yet or something? Right, something like that. I suppose in a macro, we should actually store not in operations, but rather the tokens, right? So the macro is going to be a bunch of tokens, right? So, and then those tokens are going to be materialized. Materialized, is that the word? When we start expanding the macro. Okay. So that makes sense, and that way I can just go ahead and, did I call them tokens, right? I should have called them tokens. I should have called them tokens, so this is going to be tokens, and I'm going to simply append this new token, as you can see, so we just get the next tokens and we're just appending them there. Alright, that's pretty cool, and here is an interesting thing, right? If after this loop, the token, the current token is not the type of the current token is like equal to word, or its value is not equal to end, that means we have an unfinished macro definition, right? We have an unfinished macro definition, so we have to report an error. D error expected something like end, but got that's an interesting question. What do we got? We can say something like S, and we can just use a token value, right? And we can exit with 1. So, and essentially this kind of situation may happen when you try to do something like this, right? So you tried to define a write macro, but you forgot the end, right? And it basically consumed everything, right? You forgot to put an end in here. Right, so let's actually try to see. Expected end, but got S. Okay, so I didn't do that properly, so I'm supposed to actually do it like that. Right. So it's gonna be token location plus something like, I cannot see shit in this mist. Okay, so now it's a little better, hopefully. So I cannot see behind the camera as well, so it's not visible for me too, so don't even worry about that. All right, so expected end, but got right. Yeah, there we go. So this is not a great error message, because you don't know what exactly went wrong. Expected end, why did you expect end? Right, so we don't really know why you expected end. Expected end at the end of the macro definition, right? At the end of the macro definition, but got right. Expected end at the end of the macro definition, but got this weird thing. And maybe I can even do something like that. There we go. So that's a pretty good error message, as you can see, right? And if you put something like this, right? If you put something like this, yeah, it kind of worked, right? It probably added a new macro definition to the dictionary, and then it just continued parsing everything, I suppose. Okay, so I suppose the next thing we can try to do, we need to check for redefinitions of the macros and for trying to redefine existing keywords or built-in keywords, right? So let me see. It should be probably be done some way here, right? So this kind of stuff should not be allowed, right? So you already defined right, you shouldn't be able to define right second time, but now you're able to, right? So it still says unknown word right, but it basically means that it actually passed through the phase of you know, gathering the macro. So maybe we could put something like assert false in here. Successfully edit a macro definition. Right, successfully edit a macro definition. All right. So yeah, as you can see, it successfully edit a macro definition, but then I won't be able to do that twice, right? If I want to have two macro definitions. Right, so let's actually do something like this. This is going to be info. Right, and there we go. So it successfully added two macro definitions, and then it failed on unknown right. So, okay, this is where we get the name, right? This is where we get the name. And if token value already exists in the macros, right? If it already exists in the macros, we're going to say that redefinition of the macro, right? Something like that. Error. Redefinition of already existing macro, and we're gonna put something like this in here, right? So the location is going to be a token location, right? And the name is going to be the token value, right? So this is the token value, and it would be nice to say where exactly it was defined the first time. Something like this is going to be a note. The first definition is located here. And where is it located? Well, it is located in macros token value location, and this is precisely why we wanted to actually store the location of the macro definition, right? And after that, we're going to do exit one, right? So, and it didn't help. So it didn't help at all, which is kind of weird. And you know why? Because we didn't actually add a new macro definition. That's why. All right, so I suppose we should do that some way here. So this is going to be a macros token value, and we're going to just assign it like so. There we go. I wonder if I can just do something like this. Right, so this is going to be a macro, like so, and I suppose it's going to be like referred by reference, right? So it's basically going to be part of the reference, and there we go. So we have a redefinition. Redefinition of already defined, but it couldn't print the note, right? It couldn't print the note. Why couldn't it print the note? I have no idea. I suppose this is because of that. There we go. So redefinition of already existing macro, right? The first definition is located here, and it shows the original definition in here. Would you look at that? So, and if you put them like several lines apart, right? So we can try to recompile. There we go. So here is the redefinition of the macro, and here is the first definition. Okay, pretty straightforward. Pretty straightforward, okay, so, and also, we don't want to be able to define a macro for built-in things, right? For instance, we have a built-in a plus, and defining a macro for plus should be also forbidden, right? But right now, it is allowed, right? So as you can see, it was successfully added. So luckily, we have a table called built-in words, right? So it's literally called built-in words. And this is where we can look up if such built-in word already exists, right? We can literally just check, is it a built-in word? If it is, we should throw an error. Okay, so if token value in built-in words, we're going to print d error redefinition of a built-in word. I'm going to put it like this. S, and it's going to be token location plus token value. There we go. So if I try to do that one more time, of course, I should not forget to do exit one. Of course, there we go. Redefinition of built-in word plus. Yeah, you cannot do that. You're not allowed to do that, but now if I do something like write, there we go, so it edited successfully, but we don't expand macros yet, right? So we don't expand them yet. Alrighty, so this is rather interesting. So we already know how to gather the macros. Given that there is some problem in here, because this entire parsing is rather limited, because you cannot put conditions in here, right? So if you have some sort of like 1, 10, equal if, and then you have some sort of action in here, and then you have end, this is not going to parse correctly, because the parsing of the macro will stop in here, right? So we'll need to implement some sort of a system that is aware of the blocks, but we're not going to do that right now. We're going to do that later once we have a macro system that works for simple cases. Right. So because trying to implement everything at once is kind of like is too overwhelming. Let's actually do everything like with small steps, right? So for now, I want to have a macro system that supports at least that, because that is already gives me a lot of power. I can at least have magical constant and behind some names or something, right? So I can at least have that. All right, so yeah, now we need to see how we can expand this entire thing. So we expand this thing by using a function compile token to OP. And this is a very simple function, in fact. It is extremely simple function and it's used in a single place, right? It is used in a single place, which actually makes me think that maybe we should inline this entire function, right? Maybe it makes sense to just simply inline it, because having it as a separate function actually limits what we can do with it. And one of the things I want to be able to do with it is when this word is unknown, instead of saying that it's a known word, I want to expand a macro on that word. So let's go ahead and just take this entire thing and do compile token to OP, and let's actually straight up get rid of that function, because I don't think that function is particularly useful. Right, so okay, so this is going to be something like this. So, and initially I can say that OP is going to be none, right? So this is going to be none. But maybe not. I'm not really sure. Exhaustive token handling in compile token to program, right? So compile token to program. Compile token to program. So this function is not needed anymore. This function is not needed. And here, instead of unknown word, what I want to do is, if token is in built-in words, we use a built-in word. Right, if the token is in macros, right, what we're gonna do, we're gonna take that specific macro, right, token value, and we're gonna take its tokens. And here's an interesting thing. We need to expand this entire stuff. How are we going to be expanding? We need to append it to our tokens, which means that we'll have to reverse this entire thing and append it to here. There we go. Actually, plus. Right. Something like this. Else if. And only then, if we didn't find it in macros, only then we're going to report that this is some sort of unknown word. Interestingly enough, after we appended this entire thing, I think what we need to do, we need to actually continue the entire loop, right? So we need to go on the next iteration. So yeah, we expanded this entire thing and we go on the next iteration to fetch the next token. Yes. And let me see. So this one is going to be something like OP. OP. And token is going to be token. Our tokens pop. Cool. So is that good enough? It could be. Yeah, I think it is. I think it's good enough. So we also have continue, which doesn't do IP plus 1. All right, so this is a little bit of a messy function, but I think it's fine for now. We can clean it up a little bit later. Okay, so that kind of worked, but it didn't print anything, as you can see. Right, it didn't really print anything at all, which is kind of sad, but it is what it is. Oh, I see what's going on. Yeah. Every time we're sort of like done working with a new operation, I think what we have to do in here is to append that operation at the end of the program, right? And we need to append it at the end of the program. So, and how are we going to be appending it? Oh boy, oh boy. All right. So I suppose. So this is going to be the program, and then I essentially do append OP in here. So what happened is that the program right now is completely empty, right? So I have to do load, and what is the program that we're loading right now? It is going to be a hello world, right? So this is the hello world. This is not really what I wanted to do. I actually wanted to load Porth. Right, so this is going to be Porth by. There we go. Hopefully that will work. And we have compile program. Where is the compile program? Compile tokens to. Oh yeah, compile file to program. Compile file to program. Right. So in the file is going to be examples. Hello world Porth. There we go. And as you can see, the compiled program is completely empty. So this is the problem. To fix that, I need to append these operations every time I actually successfully sort of handle them. Yep. Maybe not really at the end, but maybe at the beginning. Yeah, I think it makes sense to actually do that at the beginning. Once we successfully recognize that, we actually add it at the beginning. And then we have to do the same thing for the while and for the do, but not for the macro. Macro should not be added there. So macro is one of the things that are never reachable in the program compilation, which is kind of sus, but that's totally fine. Okay, so let's actually try to reload this. Right, so this is going to be Porth Pi. All right, so and now I'm going to try to compile file to program, and we're going to provide examples. Hello world Porth, right? So, and it's still nothing. What the hell? Excuse me? So it's supposed to work actually, but it doesn't. Even though I'm specifically appending the operations to the program, it still doesn't work, and I don't understand why. So this is really, really strange. Okay, let's actually start troubleshooting this entire thing. So compile tokens to program, right? Where do we call this thing? So compile file to program, right? And then I can do something like print, like so, print program, right? So let's actually try to see, is it empty? Yeah, it is completely empty. So inside of this thing, when I compile this entire stuff, I append the program, right? So, and when I append it, I should have at least something in here, right? So I'm going to do print program, right? So why are you not working? Could you please tell me? Okay, so things like if were never actually... Oh, I see. So this is because it has to be an else block, right? So in an else block, we do program append OP. There we go. So, and now this should work. There we go. It kind of worked, like it kind of advanced the execution. So now we have a failing program in other places, right? So specifically we have a failing in a simulation. So interestingly enough, macro is an operation, but it's an operation that is eliminated, that is erased at the compilation step. So it should never appear neither in the simulation nor generation, which is kind of weird, which means that macro keyword is something else, right? We'll have to reconsider the entire system, but for now, if we encounter the macro sort of keyword in a simulation, we're going to say that this thing is unreachable, right? So this is going to be false, unreachable. The all of the macro definitions should have been eliminated at the compilation step. right? So this should never happen, right? Let me try. There we go. As you can see, it printed hello world. How about that? So we have a program, right? We have a program that instead of calling syscalls directly, actually calls to write, right? And that write expands to a sequence 1, 1, syscall 3, right? We can even see how it works, right? So let me reload the entire thing, right? So this is going to be something like Porth pi. There we go. And we can try to lex the file. Lexing the file will load the source code file and split it into tokens, into lexems, without trying to preprocess anything or stuff like that. And let's actually take a look at the lexems of the hello world example, right? So here is the hello world, Porth, and here are lexems of hello world. Let's actually split the screen slightly because we cannot see shit in this mist. Right. So, as you can see, the lexems include macro, write, 1, 1, syscall 3. Is basically this is the source code, right? And now if I try to compile file to program, right? So instead of just loading it and splitting into lexems, I'm going to compile it into intermediate representation. It's not going to contain any macro definitions, right? So it's only going to consist of 2, 1, 1, 34. So basically push string. Oh yeah, it's actually 2. It's a push string, push integer, and syscall 3. So as you can see, after the compilation, this is intermediate representation. This macro got expanded. So this is a result of the expansion of the macro. So the macro system works as intended, right? It is working as intended, which is actually beautiful. I really like that, believe it or not. It's actually pretty cool. Right. So what do you guys think? Does anyone have any questions? 21134 minus, is this bytecode? So these are just the corresponding values of enumerations that the Python assigned, whether it's like a bytecode. Bytecode usually have like fixed standardized value for things. These values are constantly changing depending on the order of the definition, so I wouldn't say this is a bytecode per se. But it's something resembling a bytecode, I guess. So, yes. Kawaii freaking this. Interestingly enough, I think you can like define macros twice to some extent. Right, you can define a macro write, which in turn defines macro write to, which already contains, and it's not gonna work because we don't have the nested blocks and stuff like that. So it will be kind of interesting. But I think if we had nested blocks, it would be possible to have nested macros, right? And as they expand, they add to the definition, but they're not going to be scoped, I think. I don't think they're going to be scoped. But for now, whatever we have is already pretty useful. Okay, so yeah, that's pretty cool. Can we now run some tests and see if we didn't break anything? Do we even have that stuff on the compilation? Oh yeah, we didn't test the compilation. We only tested the simulation. Let's actually test the compilation. Compilation is probably not working right now. Yeah, there we go. But compilation is easy to fix, right? Because we don't have to do anything on the compilation step. Right, so this is going to be if elif op type what is it going to be? A macro, right? And this is going to be assert op type macro. Yeah, this is what I want you to have. I want you to put the similar assert in here, right? So because we're trying to compile something that contains operation macro, but it should have been illuminated at the compilation step, right? We shouldn't see this kind of thing in the generation step, which kind of hints that maybe macro shouldn't be an operation, like this keyword shouldn't be an operation, but I don't know. So maybe I will rethink the entire system a little bit later, and we'll get rid of the macro from the intermediate representation. So there is some sort of like inconsistency in here, as you can see, but that's fine. A lot of projects can contain inconsistency. Okay, so if I try to run it, it's working. As you can see, it is working. So we have a very simple macro system that you can use to, you know, have a simple code reusage. Let's actually run the tests. Right, let's run the tests. So this is going to be test by and see if we didn't break anything. And as you can see, all of the existing tests are working, right? So we didn't break anything. And let's also check the examples as well. Right, so examples will take some time to simulate. Okay, so something is already working incorrectly. Oh yeah, I see. Successfully edit a macro definition to hello. What the fuck is this? All right, so I need to remove this entire thing, right? So it's kind of useful to have tests because you spot the stuff like that. Though, by the way, I do have an interesting flag. It's called a debug flag, right? So I can put all of this kind of like debug outputs under this flag, and it's never going to be visible to the tests unless I actually provide the debug flag to the program, right? If I do something like Porth debug, and then I will try to simulate example hello world, right? Only then it will say that it successfully edited a macro definition, and also it prints the like a memory dump and stuff like that. So I have a special thing. So this kind of stuff I try to keep them and a debug flag. I'm not sure if this is that much of a useful debug information, so I'm probably going to remove it right away. So, but it's just something interesting to keep in mind. I think so far we didn't break anything, so none of the tests are breaking, as you can see, so everything is okay. We added support for simple macros, and it would be nice to actually try to use them for something. Before I go ahead and try to use them, I think I need to create a to-do. Compile tokens to program, right? I wonder what happens if you mention the macro inside itself. It will try to create another macro, but since we don't have a nested block supports, it will finish the definition at first end. I can show you what will happen, but we need a specific support for this kind of things. All right. So I can do macro write to, or you mean the macro in itself, right? So if I do, is that what you mean? That's what you mean. Yeah, it will probably indefinitely expand. Yeah, I think that's what's going to happen. I think that's what's going to happen. We can actually try to see that. So let's see. Assert our tokens len. So how big of a buffer do we want to have for the tokens, right? So let's say that it's not allowed to expand beyond 1000, right? So it's only allowed to be 1000. And if I try to do something like this, oh yeah, it keeps expanding, right? It keeps expanding, and it just, oh, it doesn't even expand. That's what's cool about it. So for this specific thing, it doesn't even expand. It actually stays at the same place. You know what I'm talking about? It just stays at the same place. So to actually start expanding, we have to do something like 69 in here, right? So, and that will basically grow, and we can try to do that. And as you can see, the amount of tokens actually exceeded 1000. So this is actually rather interesting. So maybe we should have some sort of a mechanism that prevents recursion, or at least sets the depth of the recursion. Every time, you know, the token sort of like is included, maybe we're gonna have some sort of counter that is associated with the token or something like that. That will be rather interesting. Yeah, thank you. This is a good question. So we'll need to have something that prevents like infinite recursion, or at least like some sort of like a buffer, right? Some safety mechanism. That's what I wanted to say. Some sort of a safety mechanism. Some sort of safety mechanism for recursive macros. I don't want to forbid recursive macros because I think they could be useful. The lack of recursive macros is kind of upsetting in C, so I don't want to forbid them, but we want to do at least something to make them, you know, not as dangerous as they are right now. Right, so we'll have to do something. I'm going to put it to do in here. And another thing we need to do in here is that we need to support nested blocks within the macros. So I'm going to also put it to do in here. Blocks, nested blocks within the macro definition. Support for nested blocks within the macro definition. Something like that. Something like that. There we go. All right. So right now, as you can see, it kind of doesn't work. Right. Example, hello world, this is the Porth, and in here I just want to do syscall 3. Okay, so what we have in here, okay. Add basic support for macros. I suppose I also need to document the macro stuff, because I like to document features as I implement them. So let's go ahead and do that, I suppose. Let's go ahead and do that. So here is the language reference, but in the language reference here we just have like a list of built-in words, which is fine. So I think I'm gonna say something like built-in words, and all of that is gonna become something like this. So this is a comparison, built-in words. So this is going to be the system, and so on and so forth. So these are built-in words. So interestingly, integer and string are not built-in words. They are rather data types, right? So maybe it would make sense to actually introduce something like data types, right? So data types, and the first one is going to be integer and then a string, right? So yeah, it's kind of a scuffed language reference, but at least it's something, right? At least it's something. So data types, built-in words, and then we can have something like macros, right? So let's actually put something like this: macro write one syscall 3. So define a new word write that expands into a sequence of tokens 1 syscall 3 during the compilation. There we go. So that's basically like a simple mention of the macro system in the documentation. So we're simply mentioning this entire thing, and I think that's very useful to do. All right. Okay. Document the macro system. Document the macro system. Let's push that right into the repo. And let's go ahead and see how we can use the macro system, for instance, in rule 110 for the magical constants, right? As you can see, we already use system 3 So maybe I can actually define several macros. I'm going to define a macro write, which is going to be 1 syscall 3. Might as well also define a drop. Here's the thing about syscalls. Syscalls also push the result of the syscall on top of the stack, so you can drop it if you don't want to handle it. So this is what we're going to do right now. And this way I can just do something like write. And in here I also want to define something like n, right? And n is going to be 100, right? N is the size of the board, right? N is going to be the size of the board. Let's actually see if this still compiles, just in case. Porth, compile, example, rule 110, Porth. It doesn't really compile. Least index out of range. Okay, so that is very, very interesting. That is very, very interesting. Even though I actually did OP. There is some problem in here. There's some problem in here. I wonder what. I think I know. Maybe. I have a feeling that IP should not be incremented on the macro definition. Yeah, so that's what we have to do. We have to only increment IP when it's not a macro definition. Like, yeah, we have to repeat it in here. Which yet again makes the macro definition something very, very special that doesn't really fit into our system. But that's exactly what I want you to achieve. I want you to like just see that the current system doesn't fit into the current goals, and then it will be visible how to refactor everything. Yeah, so the currently macro system just stands out and just doesn't make any sense. And now everything compiles, and if I try to run the entire thing, and everything runs. Okay, that's pretty cool. So let's go ahead and just try to use this value, right? So some of the values are actually, you know, -2. Which is rather interesting. So I'm going to replace only 100s for now. Right, so I'm going to query replace 100 with just n and see how it goes and see if it still works. It still in fact works. And for every 98, I suppose I'll have to replace every 98 with n 2 minus. Right, so luckily in postfix notation it's rather easy to do, right, and it still works. Now I should be able to easily control the size of the board from here, from a single place, and it doesn't work. I'm so happy. I wonder why. So, oh, there is another one, 101. So here is going to be like 1 plus, right? So that's what I have to do. 110 is basically a table, so nothing needs to be done in here. And there we go. So now I can control this entire thing. So I can make it 32 or I can make it 10, right? So now it is controlled from a single place at compile time. How about that? It could be 100, it could be 200. So you guys want a 200? There we go, here's 200. So that's pretty cool. And I don't have to modify the program anywhere in here, which is super convenient, I think. So yeah, this is going to be just 100. The macro system, we're already using a macro system in here. There we go. Org Photosphere, I hope I pronounced your nickname correctly. Thank you so much for Twitch Prime subscription. Thank you, thank you, thank you. And welcome to our epic macro club. So, yesu, kawaii freaking desu. That's pretty pogue. It is a neat feature. Yeah, I do agree with that. So now we don't have a magical constant 100 in here, though we have these two magical constants, which are essentially characters. And this is because we don't have character literals. It would be nice, instead of like this kind of stuff, being able to do something like this, right? That would make it even more readable, I think, but we don't support character literals. So maybe this is something that we could implement right now, since the macro system is kind of done. So what do you guys think? I think this is something that we should implement and make it even more readable. That would be cool. Alrighty. So this is sequence Porth, and in hello world there's Porth. Also, I'm thinking that, including one file into another now is actually super easy, because you just read the file as sequence of tokens, and you just append that sequence of tokens into the R tokens, right? So R tokens. It should be super easy to just add support for including files. It doesn't sound that difficult with the current system, if you know what I'm talking about. Maybe we can have like a include system. That would be interesting. Right. So because we could put shed like write into a standard library. Right, so we can just add that into a standard library, and we can have things like maybe macro read as well. We can define a lot of useful shed for syscalls, for instance, right? We can finally define shed like sys write, right, and maybe also macro std in, and we don't have to deal with this stuff anymore. So this is std in, this is sys write. You know what I'm talking about? So yeah. So we can try to do that. I've never programmed a single day in my life, but I find this super interesting. Well, thank you. That's precisely my goal. Right. Just to show people that what I'm doing is actually interesting. Okay, so let's go ahead and try to introduce the include system. Let me use macro system in rule 110 example. I'm gonna push that right into the repo. Okay. So for includes, how we're going to be doing includes? That's very interesting. So we're going to have std porth, and this is where we're going to have a macro write 11 syscall 3 end, right? So this is where we're going to have all that. And how do we want to use that? In hello world, we want to be able to do something like include, and it's going to be simply std porth, right? So include std porth, and then you'll be able to do hello world write. So this already looks pretty presentable, right? So this is something that you can put in a readme of your project, right? If you're developing a programming language, include std porth, or maybe even to make it look cooler, io porth. Right, include IO porth, meaning that you have like a separate modules for IO, for strings and some other stuff, and then you say hello world, and people instantly understand what this language does. Like this example is pretty readable, right? So this is something that I want to actually achieve. Let's see if we can do that. So this one is going to be just IO porth, yesu. Let's go to porth.py, and let's quickly add a new keyword, and it's going to be include keyword, right? Auto. Okay, so let's do porth, and let's do example hello world porth. Okay, so it's failing in here because we don't have a support for include. So now we have a new include keyword. Okay, so I forgot to update the amount of operations in here. Okay, so I should have used simulation subcommand. Okay. So this is for the blocks, and this is a very interesting thing. if we encounter something that is an include, right, that is an include, we need to check if there is a next token after include, right? If there is no tokens, we say that we expected the path to the file that you want to include, right? So this is going to be print error expected path to the file to the include file, right? To the include file, and this is going to be op log, and then you're going to do exit 1. So this kind of stuff, this kind of error may happen. Let's actually go to here. If you have this sort of situation, right? You have just include and at the end. God, please make it recursive. Oh, we're gonna get to recursion a little bit later. Don't worry about that. It's definitely going to be recursive, right? So attribute include. This is really strange. OP type in include. Okay, I see. All right, expected path to the include file. To the include file, but found nothing, right? So this is basically what happened. Expected path, but found nothing. So the next thing we need to have is the path itself. So this is going to be a token, our tokens pop, right? Our tokens pop. And if token type is not equal to token type string, we're going to specifically expect string, right? If it's not a string, we're going to say print sdd error expected path to the include file as string, but found something else. So, and this is where we're going to be using the token type human readable name thingy, right? So this is the second time we need something like this. So maybe I can split the screen in two because it's not particularly convenient, right? All right, so this one is going to be plus expected. Well, I'm actually adding the wrong thing in here. So this is that. Where is include? Okay, so here it is. I've actually, like, for a second I lost what I have in here. Okay, expected path. Okay, so now we have everything. So this is not a token type. This is going to be a token location plus token type str. So this is the token type str. And then what we found is a token type. Token type human readable. Token type human readable. Hopefully that will work. So these are pretty long messages, right? And this stuff may happen if you try to include something like 69, right? So we're trying to include 69. Expected path to the include to include file as a string, but found integer. Maybe to be string. To be string. So expected path to the include file to be string, but found integer. All right. So if I try to have something else, for instance, a word, right? So expected path to include, but found word. And if I try to include IO Porth, right? So, let's go ahead and do that. So I suppose this is going to be 1. Assert false. Okay. Okay, so yeah, it passed all of the checks. It actually passed all of the checks. So the next step we can do now, which is rather interesting, right? We can feed the file path to lex file, right? And lex file returns the sequence of tokens, right? Lex file token value, right? So we lex in the file. We'll extend a file, and then we need to append it to our tokens, right? So we need to reverse this entire thing, and then append this entire stuff to reverse tokens. And that should be it, believe it or not. That should be straight up it. Yeah. So, and after that, we just continue parsing everything. So we just keep adding this stuff. So safety mechanism for recursive includes. So what do we have in here? No such file or directory IO Porth. Okay, fair enough. So this is because we're running this entire thing from home folder, from the root. So if we move this entire thing in here, can we do that? There we go. So it compiled, actually. Yep, it compiled. We can include files. Yep, we can straight up include files, and it was actually rather easy. So if you can't include file, right, so let's actually, put something like this in here. It doesn't really print a pretty error message, unfortunately. Right, you see, it throws an exception and it doesn't tell you where exactly the problem occurred. So one of the things I'm thinking is that we can catch this exception, I think. Yeah, I think we can try to catch this exception. So try this and then accept file not found error, right? File not found, and this is where we can print a proper error message, right? Print s error file this not found, right? File this not found. And this one is going to be, I suppose, token location plus token value, right? So, and then we're going to exit with 1. There we go. And did it work? Did it work? I didn't think it worked. Can only concatenate tuples, and this is a tuple. Oh, this is not a tuple. There we go. Look at that. So it says file this not found, and you can instantly jump to this place. This is beautiful. This is absolutely beautiful. Look at that. This is so cool. Yeah, there we go. So it seems to be working. You include this stuff, and yeah, then you can have also hello world. And yeah, so there's something wrong with the simulation when you try to simulate this entire stuff. But yeah, that's so cool. And what's funny is that if you have any errors within that file, the error is going to be reported properly. You see, you're compiling hello world, but the error reporting points at IO Porth because you have a problem in here. So that's actually pretty cool. So we have a couple of things in here that we need to fix super quick. So it's kind of similar to that one. So unreachable, all the file includes. So it's literally the same thing. So unreachable, all the file includes should have been eliminated at the compilation step. Yeah, it is true. It remembers word parse token. Yes, because the token is a data class that has its own location, and location is a tuple of file path, row, and column. Right, so that's what it is. So each token has a triple associated with it, so that's why each token knows where it originated. Okay, so we have to increment this thing, I suppose, and there we go, hello world. So we need to do the same for the compilation. There we go, so here is the compilation. So here's the macro, and we're gonna just do include. All the file includes should have been eliminated at compilation step. 37, this is a 38. There we go, and it works, and if I try to compile the entire thing, it seems to be working. So there is a little bit of a problem with include path, right? Because right now the Porth compiler only searches for files within the current folder, right? So we need to implement something smarter when it comes to searching for files. So that will be rather interesting to implement as well at some point. But yep, that's pretty cool. So maybe we also need to add some sort of documentation for the stuff. Macros. Define a new word right that expands into sequence of tokens during the compilation. Include files, include tokens of file IO Porth while during. How to say that? How to document that? So maybe I'm gonna provide just an example, something like include file Porth, right? Include tokens of file Porth. Yeah. Include tokens of file Porth. So that's pretty cool. Oh, and now I can finally put a pretty cool thing into README, right? Look at that. So now this language finally looks presentable, right? So you include io.porth, and then you do hello world, and you do write. So if you never actually worked with concatenative languages or stack-based languages, you would look at this piece of code and you would know what exactly it's doing. It's actually pretty straightforward. So I really like that. So this is finally looks presentable. So maybe we can even market that. So I saw you changed 37 to 38 in 4 or 5 places. Any reason why length of types is not stored in a variable and rather hard-coded? Okay, I explained that multiple times already, but I can explain it one more time. So essentially, this assertion helps me walk through the places where I need to make changes if I want to add a new feature. This is like an old trick that I developed for myself, and I use it all the time. This trick actually works better in statically typed languages with assertions that evaluate at compile time, but since we're in Python, runtime is also fine. Right, so imagine that you want to add a new built-in keyword. Let's actually think what kind of keyword we want to add. Before I'm going to do anything, I want to compile the entire stuff. So let me do a commit, right? Add rough support for file includes. Butterbroad TV, thank you so much for 4 months. Thank you so much for 4 months of tier 1 subscription, and welcome to our Epic Compiler Club. So a draft support for file includes. All right, so let me actually see that tests pass. Hopefully they pass, and I'm going to explain what's up with all of this. All right, so all of the tests seems to be passing. Imagine that I want to add a support for new operation, right? So we have some stuff in here, right? Arithmetics, right? So in arithmetics we have plus, minus, but we don't have multiplication because we never needed multiplication. So let's actually add a multiplication, right? So this is going to be something like this. So multiplies the top of the stack with the element below the top of the stack, right? So, and semantically, this operation is doing this stuff, right? It does multiplication. Cool. So to add a new operation, I go to my huge enumeration and I add multiply to the enumeration, right? That's it. So that's the only thing I need to do to add a new operation to the language. I just add a new enumeration. And look what's going to happen. Looks what's going to happen. I try to run the tests, and tests instantly fail in a place where I do switch case on all of the enumeration, telling me that my enumeration is not fully exhaustive. It's not really a switch case. Here we have I have a table of names of the built-in words. But here is the catch. Not all of the new operation needs to be defined here, only those that introduce new built-in words. For instance, things that shouldn't be defined here are numbers, because they are not fixed words, right? But if I edit a new fixed word, I have to actually add a name in here. Don't forget to add a name in here. And then when I know that I already modified this entire thing, I just simply increment this counter and continue going to the next counter, right? So here we go. So here is the compilation. So I edit new word and I need to update compilation. But compilation is not concerned of specific words. It's only concerned of blocks. So in that case, I don't have to do anything in here. But if I edit a new block like macro, I would have to change this entire thing. So I just increment it. You see, this trick walks you through the code base and tells you what you have to do to add a new feature. So that's what I'm trying to do in here. Does it make sense? Does it explain why I have these counters hard-coded? Because there's sort of like a checklist of what you need to do. Like it walks you through the code base. And what's interesting is that you can treat it as an assertion that this code was written with an assumption that at the time when the code was written, we had 39 operation types. But since we have more, this assumption broke and you have to go back to this code and fix it so the assumption is correct again. So that's what we have in here. So it's kind of a to-do list for new features. And again, this trick works the best if you can assert these things at compile time. Right, I use it all the time in C and C++ because the latest versions of C and C++ have static assert. And you can assert this kind of stuff at compile time. So the compile process will walk you through, not just the runtime, but the compilation process will walk you through. It's even cooler than that. Assert assisted feature development, yeah, maybe. Do you already have ideas on how to implement heap allocations? We can do syscalls, so we can already call mmap. So we can already allocate memory in a heap to some extent. We can just like map some memory or something. It's already possible without any modifications. So let's actually finish the adding new feature, right? So because we have a lot of things to add here. Okay, so we need to add this thing in a simulation as well, right? If op type, right? Op type multiplication, right? A stack pop, B stack pop, and then stack append b multiplied by a, and then we increment the instruction pointer. Okay, so now we have a support for this thing in the simulation, right? So, and I forgot to increment the counter. There we go. So now we have some weird stuff in here. I think it's in the compilation. Okay, so now we have to add it for the compilation. I don't quite remember how do you do multiplication in x86-64, so we'll have to try to remember that. OP type multiplication. So for now we're going to be using the unsigned multiplication, x86-64 mul. I remember that it's mul, but I don't remember how to work with this mul. So mul accepts a single operand. It's either register or memory. It could be 8-bit, 16-bit, 32, 64-bit memory. So I think this is what we're going to have in here. And what does it do? I suppose it multiplies the stuff with AX, right? So perform unsigned multiplication of the first operand, destination operand, and the second operand, source operand. Okay, where is the second operand? I think there's a second operand. Okay, so AX src. I think this is what we want. So rex src, and then the result is going to be rex, and there's also additional stuff that goes into RDX. So as far as I know, x86-64 can multiply 128 bits, so overflow just goes into RDX, if I remember correctly. Is that correct? Do we have any professional like assembly developers in the chat? I think x86-64 like can do 128 without you know, CMD stuff. It's just like with 2 registers for whatever reason. I don't know why, but it can do that. Yeah, seems right. Okay. So, but I guess we're gonna discard RDX. I guess we're gonna just discard it, at least for now. Okay, so let's do outright. So as you can see, even though this thing is written in Python, we have a proper compiler that generates actual assembly, right? So the language itself that is written in Python is actually as fast as C. It's on the same level as C. Though it doesn't have the same optimizations like cool C compilers like Clang or GCC, but I mean, potentially it can in the future. All right, so this is going to be Mo, and we do plan to rewrite language in itself in the future, that's for sure. That is very, very important. It's very important to be self-hosted, because I never wrote a self-hosted compiler and I just want to practice that. Okay, so what we need to do, we need to pop rex, so this is the first operand, then we need to pop rbx, this is the second operand, and I suppose the thing I just need to do, I just need to multiply rbx, and that will multiply rex and rbx and save the result in rex. Overflowing into RDX, but we're gonna just ignore RDX in that case. And then I just push rex. And that's it, I guess. Do we need to do anything else? I think that is it. I think that is it, straight up. Does it compile? Oh yeah, of course I forgot to increment this entire thing. Okay, so, but we don't actually use any, you know, any arithmetic operations, so let's actually quickly add some stuff. Test arithmetics Porth. So add subtract modular. Let's do it like this. Multiply, and what we're gonna multiply, by the way, so we can try to multiply 42 and 10 and then just print the result of the multiplication. So do we want to do anything else? I think that should be fine. Alright, so I'm gonna record the tests and see if everything works correctly. Okay, so the new expected output, yeah, as you can see, yeah, multiplication works at least in the simulation correctly. But what about compilation? And compilation also works correctly. There we go. So this is how easily we added a new operation to a language that is written in a scripting language, right? So if you add shit ton of asserts, a dynamically typed language becomes actually bearable. Okay. So let me do a committee. Implement a multiply operation, right? So I want you to add multiply operation anyway, but I use it as a demonstration. So maybe this is what I'm going to do every time. Every time somebody asks about these assertions and counters, I'm going to just implement a new operation. And that way we finally will implement all of the needed operations. So that's a pretty good idea, I think. That's a pretty cool idea. Which assembler are you using? I'm using NASM. This one. I'm on a team NASM. This is because this is what I learned first, right? Some people like FASM. FASM is also a valid option, and some people like, I suppose, GAS, which is part of the, you know, infrastructure. I mean, GAS is a GNU assembly, yeah, GNU assembly, right? But I kind of got used to NASM and I like it. All right. So is there anything else I wanted to do? I do remember that I wanted to do something with includes, but I think I already did everything. Some sort of setting mechanism for includes. Include. Safety mechanism for include. Okay. Some sort of search path mechanism for includes. Right. So when we include a file, we should try to search it not only in the current path, but maybe also in a folder where, you know, the program that we're trying to compile is located. So yesu, kawaii freaking desu. But I wonder when we're gonna do all of that. So IO Porth, and to be fair, I would like to. Yeah, for now, I'm gonna just always include files from the same folder. But here's the interesting thing. So if this stuff is located in the same folder, right? The test system will try to run IO Porth as a test as well, which is kind of dumb, right? So I don't know what to do with this kind of thing. So I don't know what to do with the standard library and stuff like that. So I'll need to think about that. Maybe for now, I'm gonna just keep IO in the root folder, right? In the root folder, like so. And just running the tests on examples should work, right? So hello world is working, so everything is working. It's kind of weird, right? It's kind of weird, but it is what it is. Once we have a mechanism for searching paths, we can move this entire thing somewhere else. Right? We can move this entire thing somewhere else. It would be really nice to have also something like POSIX Porth, right? Where you would have a macro for sys write. So this is one, then sys read. It's 2 if I'm not mistaken, and for all of the sys calls and stuff like that. And then you could just use that. That would be kind of cool, right? And also macro for std in, std error, and maybe std out. I think this has to be an end. Yeah, and just have a bunch of like predefined macros and whatnot. A bunch of predefined macros, but all of that is going to be implemented later. So what's important is that we have a basis for this kind of stuff. And it wasn't that difficult to implement. It wasn't even that difficult to implement. I really like that. So it's one of these features that are relatively simple, but they give you more than they take to actually implement them. Right? So specifically, I'm really happy with rule 110 that I can finally control the size of the board in a single place, right? So now instead of 100, I can just say 10, and then it's going to be just, you know, compilation run, and what is it called? Porth. Rule 110, Porth. There we go. So now I can control that at compile time. It's going to be 20, right? So now it's 20, maybe 30, and so on and so forth. It would be also kind of interesting to be able to define macros from the command line, if you know what I'm talking about. Something like d, you know, n equal, and you can then define like 30 or something, or maybe a sequence of these things. All right. So that would be also kind of cool, if you know what I'm talking about. Yeah, I think we should put some sort of like a to do for that. So capability to define macros from command line, right? So yesu, kawaii freaking desu. So additional work, and let's push that. So I suppose the time has come to make a pull request. So we finally have a macro system. How about that? Who sits behind the camera? Is that the dabbing doll? There's only a dabbing doll behind the camera. Macros. So, does anyone have any questions, you know, about the implementation and stuff like that? Since you can allocate memory with syscalls, would it be possible to right now to rewrite print instead of it being built in? You know, allocating memory on each print sounds like a lot of waste. I think it would be better if print allocated memory on a stack. And what's interesting is that this is exactly how it is implemented in C, right? We pre-allocated a small buffer on the stack, and we just render everything into that buffer. So I think at some point we're going to have some sort of a way to allocate arrays on the stack as well. And once we have that, I will probably re-implement it. But for now, I think I'm going to keep it as a built-in. Or maybe we can have a global section of the memory somewhere that is reserved specifically for a printing. I don't know, maybe. Do you have a K-Comrade doll? You mean Matryoshka doll? No, I don't have it. Will you at some point program a debugger which will show the current stack and so on? Yes, of course, we're going to do that. What's next feature we'll add? Any thoughts? That's a good question. I don't know. I don't really know. I think the thing I'm going to do, I'm going to try to use this language for some problems, for some actual problems. And while trying to solve these problems, we'll see what's needed to implement, to be implemented. I have an idea. Let's actually have a session where I solve Project Euler problems in this language. Project Euler. Right. So the first like 100 Project Euler problems are relatively simple, and I can try to solve them in Porth. And as I solve them, it will be visible what kind of features the language lacks, and we can implement them right away. Right, essentially, I'm solving the problem, I'm missing some feature, I'm implementing that feature, and with that feature, I'm solving the problem. So that could be interesting. So, so Yesu. Yep. I think we're going to do that on the next stream. So the CI has failed for whatever reason. Let's actually see what happened. It's kind of strange. Oh, I know what happened. Yeah, type checking. So as you can see, I recently introduced like type annotations and shit, and I actually check them with MyPy on CI. For those who doesn't know, MyPy is a thing that checks these like type annotations and stuff like that. I'm gonna put that in the description. So we'll have to fix that. MyPy. Let's see. Let's see. So, do I have MyPy? Yes, I do have MyPy. Let's take a look. What do we have in here? Show me what you got. Show me what you got. Why is it so slow? Is it loading up? Okay. So, Lex file. Oh, yeah, Lex file. Has incompatible type. So the token value. All right. So we check that the token type is a string, and after that, value in a token, as far as I know, we can actually confirm that, class token, yeah, value in the token is either integer or string, right? But Lex file specifically accepts strings, but this value can potentially be integer. We have to illuminate that. So the way you do that, I think you assert that this thing is an instance of string, and that way my Pi knows that, well, it's probably a string. This is probably a bug in the lexer, right? So if the type of the token is set to be str, but the actual value is not string, this is a definite bug in the lexer, right? So it's a bug in the lexer. Okay, so what else? This is a similar situation. Right, so we also need to assert a token value is instance of the string. If it is a word, it also has to be a string. This is probably a bug in the lexer. There we go. Alrighty, so do we have anything else? There we go. So we actually fixed all of the problems. Let's run the tests just in case. Yes. And also do some examples. Examples seems to be working as well. Okay. Fix my Pi remarks. Maybe I should also set up something like flake 8, right? You know, the thing that checks for pep8. You know, it's a linter as far as I know, but I know I'm a little bit lazy to do that. I'm a little bit lazy, maybe later. Okay, does anyone have any other questions? My Pi lang. Well, didn't I actually provide you the link to this thing? I think I did. Does anyone have any other questions while we're waiting for continuous integration? So, about what we're doing and stuff like that. Did you add character constants or did you miss? I didn't add them. I don't know. So we don't really have that much time to add the character constants, but we can try. Okay, let's add them. Okay, sure. Let's add character constants. So should be relatively straightforward. So yeah, essentially we just add a character in here, and again that will basically break a lot of assertions because we also assert the amount of tokens in here. So let's take a look what kind of assertions we have failed. Okay, so this is going to be a test. Here's the first one. Okay, exhaustive token handling in compile token to program. If token type if token type token. Oh shit, I just realized the very interesting thing that every time we update the tokens, we also have to update this place, right? We also have to update this place because maybe a new token type will update the value. Will update the value. Alright, so I wonder if I can just put assert in here. I don't think I can just put assert in here, so I think I'll have to do something like assert lang token type equal for exhaustive token type definition, right? The value field of the token data class may require an update, right? Something like this. This is essentially what I'm trying to do in here. Len token type. So So where I was doing all of this, I forgot. Okay, so if it is a character, right? If it is a character, the operation we're doing in here, I suppose we need to turn it into a push integer, right? So op type push integer, and the value is going to be token value, right? So this one is going to be a token value. And what can I use in here? I think I can use ORD, right? Something like this. And let me take a look at the help for ORD. Return a code for one character string. Okay, so maybe that's exactly what I want to have in here. ORD, there we go. And location is going to be token location. Cool. So, and after that, I'm going to say that we handle this stuff, essentially handle this stuff. Okay, so do we have anything else? Associated with true, perhaps remove parentheses. Yeah, sure. Okay. Anything else? That's it. That's surprisingly weird. Oh, this is because we never used the characters yet. Okay, so that's fine. So if I go to rule 110, right? So example, rule 110 Porth, right? So and 42, if I remember correctly, is this one, and this is a space, right? So let's see what's gonna happen. Porth simulate example rule 110 Porth. Okay, a known word that, which is fair enough. We don't know how to lex these words. So lex file, right? So lex file, the famous podcaster lex file. So, and I think we do that in a lex line. Right, there we go. Okay, so as you can see, if we start with double quote, we try to parse it as a string. So we have another thing in here. Else if line column equal a single quote, right? If it is equal to single quote, we need to. I suppose it's going to be the same. It's just we have to do shit slightly differently. So, all right, I'm trying to find the first, the ending quote. If I don't find such thing in here, right? That means we have unclosed character literal, then we take the text of token and we turn it into a character token, and then we continue. Okay, so it's pretty much the same. It's just like the wrappers are different. And here we have a char, right? So this is a character. Another interesting thing is that maybe if the length of the text of token is greater than, is not equal to 1, right? We can say something about that, right? We can say that the character is too long, right? At least for now, right? At least for now, but maybe not. I don't know, because here we also try to unescape the string or something. So I'm gonna actually don't do that for now, and we'll see how it goes. All right, so it seems to be working, as you can see. It seems to be working. What about the compilation? I'm going to try to compile the entire thing and also run it. And it seems to be working. And now we should be able to quite easily change. We should be able to swap out, for example, space with a dot. Will that work? It does work. Now, instead of space, we have a dot. What about hash instead of asterisk? And now there we go. So we have character literals. Doesn't the print support non-ASCII characters? No, probably not. Does not support that. But we can have maybe a to-do for that. We just implemented it. I don't think it supports much. So we do escaping in here though, but I'll have to think how to implement all that. But yeah, we have basic character literals. It's just I just hack them together, and yep, it's pretty cool. So is that what you guys want? So it took not that much, right? So this is the entire thing, and now we have character literals. I wonder if is this really it? Because I remember like we had more places with this kind of stuff. Oh yeah, okay, so exhaustive handling. So this is the problem with dynamic languages, right? So to know that this thing fails, I need to have a test that tries, right? Where is the Porth? I need a Porth file. I need a test that tries to use a character for a macro, right? Otherwise, I would never know that there is additional assertion in here. Yeah, I would never know. Like in a statically typed language, it's not a problem, but in a dynamically, you need to have a set of tests, a suite of tests that runs through all of the possible execution paths, right? So it's kind of interesting. Like, I don't know why it is not obvious for a lot of people on why statically typed languages are better than dynamically typed languages. This is a good example. In a dynamically typed language, you need to have a full set, a full suite of tests that always, all the time, go through all of the execution paths. In statically typed languages, this you don't have to do that because the compiler meta executes all of the executable paths by type checking. The type checking process actually goes through all of the execution paths and checks that, you know, everything is okay there. And I don't know, like the conversation like dynamic versus static for me is just non-existent because of this, right? So you don't have to do that in a statically typed language, you get it for free. But again, some people strongly disagree with that kind of stuff, and I really don't understand them. I don't know why. Even very experienced software developers, by the way, even very experienced with like decades of software development, still think sometimes that dynamic languages are better. It's really weird. Maybe I'm just dumb. Who knows? So we have unreachable in here and elif type token type character return character. That's what I wanted to do. So it's just like a human readable name. I expected macro name to be a word but found character. So that's precisely what I wanted to see in here. There we go. People can have different ideas, nothing wrong with that, I suppose, I guess. If people like to be wrong, so it's just like, who am I to tell them what to do? We'll live in a free country, goddammit. Hey, we bro. Okay, so, cool. Did you implement LR parser? I have no idea what it is, believe it or not. So, you want to see my parser, by the way. You want to see my parser, lex file. So this is my parser. This is the entire parser. And with this entire parser, we implemented a compiler that compiles this thing into assembler, that looks like this, right? So this is the assembler generated from that source code. And if you run the program that got generated, right, it generates a rule 110, demonstrating that this entire thing is Turing complete. I have no idea what is LLR parser. I have no idea what it is. I'm sorry. I just don't have a formal education. I just split the lines and generated a bunch of assembly code, and this is what the code is output. All right, so that's pretty cool. Implement character literals. There we go. Let's push that right into the repo. Does anyone have any other questions? Very productive coding session. You edit macros, includes in characters. Yeah, it is actually pretty productive. I didn't expect that. Huh, it's pretty cool. I only planned to add macros. I thought it's gonna take like 2 hours, but apparently we had enough times to implement includes and character literals. Though macros and includes are not really finished yet, right? So there's no safety mechanisms for recursive situations, and macros still don't support like nested blocks and stuff like that, but I created separate to-dos for that, so eventually we're gonna implement it. Wouldn't dictionaries help you with keeping all that exhaustive handling? Exhaustive handling. How would it help me? How would it help me? I'm not sure how it would help me. Okay, so how it would help me to remind that if I edit a new token in here, I should not forget to maybe add a new type in here, or maybe not. I don't know. So for instance, we edit a character in here, and if I edit a character, I don't really have to add a new type to the union because character is an integer. But if I add a float, right, if I add a float, I do need to add a new type in here for a float. So how dictionaries would help me to remind me that sometimes, depending on the situation, I have to add a new type in here. Please elaborate how it would help me to do that. I would really like to know. For example, dictionaries for operators to function then before. We do have that. There we go. So we have a dictionary for a built-in word into a type of the word. But here's an interesting thing. Not all of the operators are fixed. Some of them are changing all the time. For example, integers. Integers act like operations because they push an integer onto the stack. You cannot put this thing in here. It's yet another case that depending on what kind of operation you add, you either have to add it here or not add it here. So how dictionaries exactly help me to remember that I need to go through all of these places and sometimes add a thing and sometimes don't add a thing, depending on the situation. I don't know how it will help me. Do you plan on adding something analogous to structs? Yeah, of course. We need some sort of way to describe a schema of the memory, and structures are really important for that. Yeah, so we're going to have some sort of structures, of course. I'm not even sure. Does Porth have something for structures? I'm not quite sure. Anyways. Will you do type checking? Yes, we will do type checking. This is actually a very cool question. So the way we're going to do type checking is similar to how WebAssembly does verification step. Right, so in WebAssembly, there is a pretty cool thing called verification. Basically, what it does, it literally type checks WebAssembly. WebAssembly type checking. And WebAssembly is kind of similar to Porth, right? It's kind of similar to Porth, like it pushes integers onto the stack, plus operations also operates on the stack and stuff like that. And essentially type checking is performed like so. Right, so you have 10, 20, and plus. The type checker evaluates your program, but instead of pushing specific values onto the stack, it pushes the types, right? It sees 10 and it pushes integer onto the stack. Then it sees 20 and it pushes integer onto the stack. Then it sees plus and it knows that plus accepts 2 integers and returns a new integer. So it will just remove that and put an integer in here. And it will go through all of the execution paths of your application, sort of the meta evaluation that I was talking about, and then check that all of the operations stack up and none of the training elements in the stack remain. So we're going to do a similar thing. We're definitely going to do a similar thing. It's a good question. It is freaking cool. So read that article. I put that article in description for people who watch on YouTube, and I also push it into the chat. This is a very cool idea, right? And it's implemented in a WebAssembly. So every time a WebAssembly is loaded by a browser is instructed before trying to evaluate that WebAssembly, verify that it type checks. Dexter the Genius, thank you so much for 3 months of Twitch Prime subscription. Thank you. Yeah. Sounds awesome. So it can be completely separate to the compiler stage. Yes. Yes. As far as I know, Porth doesn't do anything like that. Porth is a dynamic language. I plan this thing to be static and compilable. So it's gonna have like a type system, a proper type system. Furthermore, well, I'm probably not going to spoil, so I'm going to leave it for the next streams. Had an assignment where a program had to identify tokens and numerics, create a dictionary of tokens, and separated strings with spaces. Any other solutions to do the same? I don't know. I guess I would do the same. What about classes objects? This is a procedural language. We're not going to have classes as an objects. Have you seen Kitten? I haven't seen Kitten. Oh, right. Okay, so I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you next time. Next time we're probably gonna try to solve some project Euler problems and try to understand what needs to be added to the language. Check out all the links, check out the description. If you're watching on YouTube, check out my Twitch channel. It's twitch.tv/Tsoding. If you're watching on Twitch channel, check out the YouTube channel where I upload all these things. And I gotta go. Thanks everyone for watching. Love you.